Hello ma'am, good morning. I'm Nilofer from CSE1. My roll number is 58. The experiment which I've got is generating the quadruples of a given arithmetic expression. Now what is a quadruple? Quadruple, from the name we can say that it consists of 4 parts. Now we are not sure of what are these 4 parts. We have a 3 address code, and for implementing the 3 address code, one way of implementing is quadruple. The other is triple, we have indirect triples and many. So now in quadruple, we have 4 fields. Means every instruction from the 3 address code is being split into 4 fields. These 4 fields are operator is one field, operand, the first operand or the argument 1 is the second field, and the next is the third field is the argument 2 or the second operand, and the result being stored. Say we have C is equal to A plus B. That is the 3 address code. Suppose. Now, in the quadruple, it is represented as operator is plus, the first operand is A, the second operand is B, and the third, and the result is getting stored in C. So we write it like that. Now let us see how we try to implement it. So here we can see that we have created a structure called quad. In this quad, we have the attributes we have are, one is the operator, the next two are operands, and the next one is the result. So now we are reading the input like as so, and now we are copying it like the first we are taking it into operator, which is here we have defined only two. One is plus and one is the multiplication. So additional multiplication we have implemented here. So we are first copying it, the operator, and now the operator is always in between two operands. So if we number them, we'll have 1, 2, and 3. So the second one is always the operator. So operator directly we are defining as plus. Now we don't know what the arguments are. That is, what are the operands being used. We may have A plus B or X plus Y or C plus D. We don't know. So we are saying argument 1 is $1, which represents the first operand. And argument 2, we are taking the third one because the second one is the operator. The third one would be the second operand. And now we are computing the result and storing it. Similarly, we are applying this for multiplication also, like this. So I would like to explain this with help of an example. So let me share my screen again. Yes. So here we can see I'm trying to generate the quadruples, and the given expression is A plus B star C. Here the operand having higher precedence is B star C. So first it will get computed and the value is getting stored in T1. And now the result is getting added to A. So we represent this is the 3 address code. And now the quadruple would be the 4 fields here. First, the quadruple means we'll have 4 fields. Now let us see. The operator is being represented as OP. Next, the argument 1 or the first operand is represented as arg1, and the second operand as arg2, and the result of where it is getting stored. So here we can see star is the operator here, and then the first argument is B, and the second argument is C. So we are computing this and storing it in T1. It automatically capitalizes it. And now the second operator is plus. We are adding it. What are we adding? We are adding the value of A with T1, and this value is getting stored as T2. So this is how it is. And now let us take another example, which is, let us say A plus C plus D star F plus E. So the 3 address code generated for this would be T1. T1 is equal to D star F. And now we'll keep on adding one by one. So next T2 is equal to, what will it be? Means it'll be C plus T1. And now T3 is equal to a plus t2. And then lastly, we have another variable which is e. So we'll be storing t4 is equal to t3 plus e. So we have computed. Now, instead of creating number of temporary variables in our program, what we have done is we have just taken the value of b, suppose here we see d star f, and we have stored it in d itself. So we can reduce the memory size. Instead of creating number of temporary variables, we'll use the given variables as it is. So from this, if we write the quadruples, it will be arc1, arc2, and result. So the first operator being used is star, and the next is we have d star f, which is getting stored in t1. Good. And now we have the next one as plus. The plus we adding is c plus t1, and the value is getting stored in t2. And next we are having the plus operator, and now we are using it for, we are adding a and t2 and storing the value in t3. And next again we are computing to again we are having the operator as plus. Now we are adding it, and then what are we adding this time is t3 with e, and storing the value is t4. So this is how it is. Now let us run the program and check for these two inputs. So for running the Lex programs, we have to, obviously we have to be in the same directory where we have. So I have them on my desktop, and now the commands would be Lex space filename.l, and then we have YACC space. I'm sure this is for the parser. I mean, how the parsing technique goes on. Quad.y, and then we have GCC space lex.yy.c. This is where we'll be compiling it. So now I've made a mistake. I've typed incorrectly. So again, I'm trying to execute it. So first we are running the Lex program. So it'll be this one. And the next command is this one. We have no errors as of now. And now the next command is this one. So here is where we are compiling and checking if we have any errors. So as of now, we have no errors. That means we can execute the program. So for execution, we have the standard way, which is /a.out, which is the same we use for the C programs as well. So now it is waiting for us to give the input. Now the input we'll be giving is a plus b star c. So as we have already seen, it should be generating this kind, as we have already tried. Now let us compare the variation between how we have defined, how we have the theoretical knowledge, and how is it different from the practical one. So now I've tried to execute. Here we can see that b star c is getting stored in b rather than a new variable. That means instead of creating number of variables, we are using the given variables to store a program, to calculate, to make the computations. And now as it is stored in B, now we'll have to add it to A, as it is A plus B star C. Now for adding it to A, now B star C is present in B itself. The value is being computed and stored in B. Now if we simply add A plus B, it would be sufficient. And now A plus B is getting stored in A again. So it is easier for us, and it also reduces the space used. And now as we, I would like to say that point again, because in the next program, if we see, again, I'm trying to execute, and the next input is A plus C plus D star F plus E. We have 1, 2, 3, 4, 5 variables. If we keep on going, if we keep on creating temporary variables, we end up with 4 temporary variables. Here we have 4, and then here we have 5, which is a total 9 variables. So it uses a lot of memory space. So what we do is we store them in in the variables used itself. That is, a plus c is getting stored in a. Again, d star f is stored in d. And now we'll have to add, so we simply add these two, which is a plus d. And again, we'll store it in a. So finally, we are getting only one variable which is already present rather than creating a new temporary variable always. Now, this program is valid for a valid string. So what if we give an invalid string? Invalid string looks something like this. So how can I say, how am I telling that it is an invalid string? It is because star B doesn't make a sense, because if we can't have two operators without an operand in between, so we need to have. We also may have a doubt why that isn't true in all cases. Yes, it is not true only in case of negative. That is, if we have the value as negative b, then it is valid because it is saying if the digit is positive or negative. If it is positive, we don't represent, but if it is negative, we'll have to put a minus over here. So star b doesn't make any sense. So it is an invalid string. So it says syntax error. So that is how you generate quadruples from a given, for a given arithmetic expression by using the 3 address code. Thank you.